lifting assembly. This is an extra credit assignment. Okay, so this is optional. All right, so we're going to model these 4 parts and we're going to assemble it. We're only going to create one assembly for this assignment. Okay, so we're going to first model the base plate. Then we'll go to the second page and model the other 3 parts. These are the detailed drawings for each of the parts. Okay, so let's start with the base plate. Okay, so the base plate, we're going to draw a sketch, length of 30 or height of 30, length of 160, height of 30 again, and radius of 10. Okay, so we'll do a radius of 10. All right, so let's go to CATIA and let's go to Start, Mechanical Design, and Part Design. And okay. All right, so I'm going to do my sketch on this vertical plane. You can choose any plane you like. Go to Sketcher, and I'm going to use the Profile command. And by the way, if you don't see your sketch tools, it's very common to accidentally turn off your sketch tools when you're first learning a CATIA. Right click on any icon and turn on your sketch tools toolbar. All right, so I'm going to use Profile, and I'm going to keep it symmetrical about the vertical. So I'm going to draw that U shape. And try and keep it symmetrical. Okay, you can hit escape or just click on the icon to exit. All right, so I want symmetry between these 2 vertical lines. So I'm going to hold on to the control key, select those, and then lastly you pick your line of symmetry, which is the vertical axis of the sketch. This is the horizontal. We're going to use the vertical, and we're going to add a symmetry constraint. Okay, and now you can see the symmetry symbols. So they are symmetrical about the vertical. So if I was to take this line and stretch it out, you can see it'll keep it equidistant from the line to the vertical, and same thing with the other line to vertical. They will always be equidistant, equally distant. All right, so let's add the 160 length. So dimensional constraint, this is 160. Height of 30 for each side. All right, so now we can go ahead and fill it. All right, so let's go ahead and fill it. This side first. And the fillets are 10. It's giving me a warning because it recognizes that we have this constraint of 160. I'll come back to this. So it's telling me, hey, it's impossible. Do you still want to trim it off? Trim off the excess? Yes. And yes. Okay, so let me change this to 30. And enter. Oh, my mistake. It's 10. Radius of 10. There it is. Okay, so it gave me that error message because this line is no longer 160. It trimmed off the excess, but it's telling me, hey, you know what? But to the intersection point, we'll maintain that constraint of 160. We're going to have the same thing happen on this side. So let's put a fillet on this side. It's giving me the same warning. Yes. I'll accept the consequences by adding this new constraint. Let me hit escape. I'm having trouble selecting this. Double click. There it is, 10, and enter. All right, so once again, when I created these 2 fillets, radius of 10 each, this line is no longer 160, so that's why we were getting that warning sign. So CATIA said, hey, we'll keep the 160, but to the intersection point between the horizontal and the vertical. And same thing on this side. So that's a distance of 160. All right, so now let's do a tool sketch analysis. Now, as you can see, it's telling us, hey, this is open. It's not a closed profile. See the cyan circles? Anytime you see cyan circles, that'll indicate that there's either a gap or an overlap. Okay, so we're going to break the rule this time and leave it open. Okay, so we'll leave it open. We'll accept the consequences. So now let's go ahead and pad. Let's exit the sketch. And we're going to do a pad of the sketch. And it's going to give us a warning saying, hey, this is not a closed profile. And there it is. So we're doing the pad. It's giving us a warning. Are you sure you want to select this sketch? It'll work if you choose the thick option. Okay, we'll accept it. Yes. So if we go back to the PDF, we can see that this has a thickness of 10. Thickness of 10. Okay, so this is the way we're going to be able to use pad. Since we don't have a close profile, it'll allow us to use the profile as long as we add that thickness. Okay. Another thing I forgot is the length. This length is 75, so we have a thickness of 10 and a depth of 75. All right, so we're going to click the thick option. So we're going to add thickness to this, thickness, and go to where the area where it says thickness. So the default is 1. I'm going to change the thickness to 10. Okay, so in this case, it's going to thicken in one direction 10 millimeters. You can also thicken in the opposite direction. We're only going to thicken inward 10 millimeters. But if you also wanted to thicken in the outward direction, you can also add a number here. If you wanted to cut it in half, you could set neutral, and it would thicken half in one direction, half in the other. So it'll take 10, thicken 5 in one direction, 5 in the other. But we're just going to go inward. So I'll turn this off, and we'll go 10 inward. So it's already given us a preview. As you can see, preview. It's thickening 10 inward from our profile sketch. It's thickening inward. Okay, so now we need a length of 75. So I'm going to type in 75 for our length and preview. But I want to keep it symmetrical. Instead of going 75 in one direction, I'm going to cut it in half and go 37.5 in each direction. Okay, so I'm going to go 37.5. So I'm going to go mirrored. But I don't want to thicken it, or my mistake, lengthen it 75 in each direction. I'm going to cut it in half, 37.5. Preview. There it is, 37.5 plus 37.5 is 75. And we thickened inward 10 millimeters. And okay, there it is. All right, might as well name this part. Right-click Properties at the top of the tree. And this is our base plate. And okay. Okay, so might as well name it. There it is. Now let's go ahead and do the slot here on the side. Okay, so here we have a slot. Has a depth of 10 to the center. So to the center of the arc or scallop. To the top here is 10 millimeters. And the opening is 11. All right, so let's do a sketch here on the surface, or you can do it on the plane. I prefer to do sketches on planes because if you were to create a sketch on a solid and the solid gets altered or deleted, that sketch can no longer exist. But I'll break my own rule and I'll go ahead and sketch on the surface, on the solid. Okay, I'm going to show you a little trick. Let me hit normal to see it parallel. There it is. Double click on the toolbar to send it back in place, dock it back in place. Instead of having to draw an arc and 2 lines for our slot, I'm going to use one of my favorite commands. Go to the rectangle command, go to the pull down, and go to elongated hole. Okay, so I'm going to click on elongated hole. And I'm just going to pick a point here in space. Make sure it stays vertical. And you can see what I'm doing. So instead of having to draw two lines, a circle, and trim or erase elements, I can just do this all in one shot using the elongated hole command. Okay, so the opening is 11. So I'm just going to cut this in half. Half of 11 is 5.5. And okay, there it is. And the depth from the top to the center is 10 millimeters. So let's put a dimensional constraint on the top from the edge here to the center of the arc. And this is 10. Okay, it's not completely constrained. We don't have an overall length of the slot. It doesn't really matter what the length is. We're only going to cut through this portion. This is just going to cut through air. So it doesn't really matter as long as it's not inside the solid. We want this arc outside the solid. We can add any dimension we want. So I'll add any dimension to this construction line. I'll make it 20. Doesn't matter. As long as this arc is outside the solid, or I should say beyond the solid. All right, so let's do a tool sketch analysis. Everything's closed. It looks good. Okay, let's exit and do our pocket. Okay, so let's go ahead and do our pocket of this sketch, the second sketch. Do the pocket. And we're only going to go up to the next surface. See, preview. Whoa, I don't want to go through the entire thing. I thought it was only going to go up to this surface, but it went up to all the way up to the end. Okay, so I can say, you know what, I'll just do a dimension. Doesn't matter as long as it only goes through the first wall here, as long as it doesn't go to the next wall. Preview. Okay, so the length, as long as it's 10 or more, it'll work. Okay, the wall thickness is 10, so as long as I use a minimum of 10 for my depth dimension, it'll work. And hit OK. There it is. Okay, let's go ahead and add the hole. So we have a hole of 32. So the hole of 32 in diameter, we're going to locate it 37.5 from the edge and 60 from this edge. All right, so let's go ahead and locate that hole. Okay, so what I'm going to do is pre-select this edge. And we're going to go 37.5 in. Now, I don't have an edge to pick here, so you know what? I'll pick this edge. And hold on to the control key. So as you can see, this edge is red, so is this one. Make sure you hold on to the control key when you select more than one element. In this case, we selected these two edges shown in red. Now we can go to the hole command. So click on the hole command and place the hole, guesstimate the location, click. All right, so our diameter, let's type in our diameter. Diameter is 32. And the depth, instead of typing in a blind dimension, we'll go all the way up to last. Let's hit preview. There it is. Okay, now it's not in the right location. Now here we have our dimensions. They're hard to see. But see, that's the dimension from this edge. So it takes the edge and projects it to the sketch plane. It goes across. So this dimension is 60. So type in 60, enter. Then it's hard to see we have this dimension here. Let's clear it out. And that's 37.5. Double click on it. 37.5. And OK. And there it is, correctly located. Preview. And there's the hole. Hit OK. Okay, the only thing missing now are the fillets. So we have 2mm fillets here. Okay, so let's do fillet. So go to fillet. Now don't make the mistake of picking the surface. Watch what happens when I hit preview. It's going to try and fillet all the edges of that surface. Okay, let me cancel. What you want to do is fillet only the edge. Okay, so fillet. Don't make the mistake of picking the surface. Pick the edge. Be patient. Click. There it is. And click its opposite edge. And the fillets, notice how it's red. So when you see red, that means that it's only picking an edge. If you were to click the surface, it would turn everything orange. In this case, we want to see red. And the radius is 2 millimeters. And okay, there it is. And it looks like we're done with this base plate. You can go ahead and save it now if you like. I'm going to go ahead and start the next detail view, or I should say detail part. So I can go to Start, Part Design. It's going to open up a new window. Part Design, and hit OK. It's going to open up a new window. Don't panic, you have not lost the base plate. If you go to Window, see there it is, base plate. You can always go back to it. I can go window vertical to show you that it's still there, and my new part. Okay, so notice this is blue, telling me this window is active. If I click on this one, it'll turn blue. If I double click, or I can maximize. Okay, there it is. So let's go ahead and draw the next part. Okay, so let's start with, let's do the lifting block first. Okay, so let's do the lifting block, and then we'll work our way down to the sliding block and then the lifting screw. Okay, lifting block. Okay, so we're going to start by drawing this profile. So we'll make it 100 by 25, angle 15 degrees. Okay, and oh, here it is. I was looking for this dimension, and 7. Okay, so we have this 7 from the intersection point to intersection point, angle 15, length 100, and height of 25. All right, so let's start with the sketch here, and we'll keep it symmetrical. Okay, so I'll use the vertical, the YZ plane, draw our sketch. All right, so let's use the profile. Okay, this time I'm not going to keep it symmetrical like the first one, but I will start at the origin. Okay, so we have a height of 25, so let's just guesstimate, and a length of 100, and then we're going to go down 7 at some angle, and let's go ahead and close it. So there's a rough profile of our sketch. Now let's go ahead and add our dimensions. We know the overall length is 100. Okay, well, let me adjust this. Since the objects are not constrained, I can still make some adjustments. There it is. Let's go ahead and add the dimension of 7. I should have done that one first so that the profile doesn't jump all over the place as I'm adding constraints. This one should have been first. 7. Okay, and we have an angle of 15 degrees. Okay, and we have a height of 25. Okay, so there's our profile. Do a tool sketch analysis. Everything's closed, everything looks good, and let's go ahead and do our pad. All right, so we're going to go ahead and do a pad. Go back to our drawing. This has a length of 100. So I'm going to go 50 in each direction for a total of 100 for the pad. So let's do the pad. And I'm going to go mirrored. So it'll go in both directions. And we're going to type in 50 for our length. Preview. There it is. So notice it's going 50 and 50 because we went mirrored. So 50 in each direction, total of 100. And OK. Okay, let's go ahead and draw the top here. Okay, so we're going to draw a circle and then do a shaft or a pad for the shaft. Okay, so let's go ahead and sketch here on the surface. Okay, so let's draw a circle. Okay, circle with a diameter of 85. Okay, now we need to center it. It's already constrained to the vertical. Okay, so we still need to center it, see how we can freely move it vertically. So that means we need a vertical constraint. So we'll put a vertical constraint from this edge to its center. Center, there it is. And that would be a 50. So that circle is centered about this block. This 100 by 100 block. So take half of 100 and we get 50. And there it is. Go ahead and exit. Should have done a sketch analysis, but pretty sure it's good. Now we can do our pad of our cylinder or our circle to create our shaft. Okay, so let's go ahead and look at the height. This has a height of 3. Okay, so height of 3 for this pad. And okay, and there it is. Okay, and now we have a hole at the center. Okay, so this hole has a diameter of 32. Okay, so hole diameter of 32 and it's going to go all the way through. All right, so let's go to hole command. I'm going to select the edge of the shaft. So by selecting the edge, it's going to center it with that circle. Okay, and then click, and you can see it centers it about that circular edge. Okay, and the diameter is 32. And we're going to go all the way through, all the way to last. Okay, and preview. And there it is. Okay, so now we need a little pocket here. So if we go back to the drawing, we're almost there. We have this little pocket of 2. So 2 millimeters. It looks like I'm missing a dimension. Okay, so this is 2 millimeters from this edge down to here. Oh, here it is, the overall length of 92. Okay, so this is 92. These are the 2 dimensions I was looking for. 92 and 2. So let's go ahead and draw a sketch on the surface. And then we'll do a pocket going in this direction, but we're not going to use pocket. We're going to use a different command. We're going to use the slot command. Okay, so let's go ahead and draw the sketch on this surface. All right, so we're going to go ahead and use the rectangle command. But instead of using the rectangle command, I'm going to go with centered rectangle. Centered rectangle, and I'm going to use the vertical axis. Okay, so this rectangle is going to be centered about the vertical. I know it's up here. Let me do it up here, and then I'll come back and adjust it. Click. Notice it's going to keep the square symmetrical about this point. Okay, so I'm just going to guesstimate the length. Okay, then I'm going to grab it by the point here and bring it down. Okay, there it is. So we know we have a length of 92. Okay, so this is 92. And okay. And we know we have a distance of 2 millimeters. Okay, change it to 2. All right, so this length doesn't really matter because we're going to end up doing a rib, and this is going to cut through space in this area, and this part here is going to cut through solid. Okay, so as long as this line is beyond this edge here, as long as it's beyond that edge, doesn't matter how long it is. Okay, so let me hit normal to adjust my screen. There it is. So I'll go ahead and add any random length. 10 sounds good. Round it off. Okay, do a tool sketch analysis. Everything's closed. Everything looks good. Let's exit. Okay, so now I'm going to do what's called a slot. Okay, so this is the slot command. Haven't used it yet, so slot command. So we're going to pre-select our sketch. Okay, so select the sketch. As you can see, it's orange, it's pre-selected. And we're going to hit slot. Okay, so you can see our profile is our sketch, in this case, sketch 4. And now we need a curve, center curve. So we need a path. So I'm just going to pick this edge, or we could have picked this edge over here. Either one will work. I'll pick this edge as my direction. As you can see, it's already cutting through. Okay, so we pick our profile, which is the sketch, and the edge for direction, and preview. And there it is. Oh, we actually have to go beyond. We have to go beyond this edge, further downward. Okay, let me go ahead and cancel that. So I'm going to use a different method. So it's limited to this length. If I would have had a long line, which typically I would have a long line to give it direction and length, but since we don't cover surfacing and wireframe in this class, let me find another way. So let me cancel that. I'm going to cancel. So I'm going to use a different approach. We're still going to use pocket. So let's go back to pocket. At least now we know how to use slot. Let's go to pocket. I'm going to use the exact same approach. So let's go to pocket. I'm going to pick my sketch. And let me click on more. Oh, I was looking for direction. Oh, here we go. Okay, so normally when you do a pad or a pocket, it'll go normal to your sketch, perpendicular to the sketch. And here's the default, normal to profile. But this time we're not going to go normal. We're going to go with respect to this edge. So let's turn off normal. We'll turn it off. So click in this box, it's blue, pick the edge. And now it's going to pocket in this direction. And let's increase the length. So now I'll be able to cut all the way through. So you can see previously I couldn't do it, but now I'll be able to cut through. It's okay if you go beyond. Okay, hit preview. And this time it worked. Okay, and hit OK. So there it is. We have our pocket. Okay, all we need to do now is go back and do some fillets. Okay, so let's go back to our PDF file. Okay, so the fillets. I don't see the collar. Oh, here it is. So fillets. So if you don't see a fillet on here, look for a note. And here's our note. Fillets, radius, 3 millimeters. Okay, so we're going to use a 3 millimeter radius all the way around. And you know what? I just realized that this 2 is not from the top. It's actually from the bottom. So I need to go back and change my mistake. Fix this sketch. The sketch I have here, I went 2 millimeters from the top when it should be from the bottom. Let me go back and fix that. So I'm going to go back to this sketch. So I mistakenly went with 2 millimeters from the top edge when it should have been from this edge. Okay, so let me delete this. And let's throw in the 2 millimeters from this bottom edge and not the top like I did earlier. Okay, so let's pick this bottom edge. Click the profile, horizontal line. Okay, and change this to 2. And okay, there it is. Okay, let's go ahead and exit. And it'll adjust, it'll update. There it is, it fixes it, it updates. Okay, so let's go ahead and add our radius of 3 millimeters all around. Okay, so in this case, we are going to pick surfaces. So watch what happens. So let's go to fillet. Let me double click on this one so it'll dock it back in place. Whoa, it docked it somewhere where it shouldn't have. Let me reset my toolbars. I'm going to go down to customize, go way down to customize. So right click on any icon, go all the way down to customize, go to toolbars and restore position to the default position. There it is, and close. Okay, so we're going to go ahead and fillet 3 millimeters, fillet. Let's type in 3 millimeters. Okay, so now let's go ahead and pick surfaces. So we're going to pick this surface, hit preview. You can see it's going to fillet all the way around. So this time, instead of picking one edge at a time, I'm going to just pick the surfaces. I'm going to fillet this side. We're going to fillet this side. Hit preview. See, it's going to fillet all the way around. And we're also going to fillet this top surface. And preview. There it is. So notice here that it shows you orange, telling you it's picking the edges of the surfaces. Okay, and hit OK. There it is. We did it all in one shot. We did all our filleting in one shot, as you can see. Okay, so we're done with this part. Let's go ahead and label it. Forgot to label it. Right click properties, and this is the lifting block. And okay. Okay, so that's it with this part. And let's go ahead and add some color to it. Okay, I'm gonna go right click properties, give it some color. I want you to get into the habit of adding color, or get comfortable with adding color. So the first one is to add color to the surface. Second one is to change the edge color. The default is black edges. Okay, so, oh, and this is for points. And this is for lines and curves out in space. This is for edges on solids. And this is for the surfaces. Okay, let's give it I'm going to go to rainbow colors, more colors. I'm going to pick a purple color. And okay, apply. There it is, and okay. Okay, let me go to my base plate and give it a color. Okay, right click on the part body, properties, pick a color. Yeah, I'll pick tan or light brown, and okay, there it is. Okay, so now let's move on to the sliding block. Okay, so let's go ahead and create the sliding block. And we have an overall length of 90. And this length is 100. So 100 by 90. And we're going to pretty much do a similar approach as we did here. We'll do this sketch. length of 100, then go 6 up, angle of 15 degrees, and a height of 25. So height of 25, 100 length, 6 in height, angle 15. All right, so let's go back to CATIA, and let's go ahead and go to Start, Mechanical Design, Part Design, and OK. All right, you can always go back to the other parts you've already modeled. You can go to Windows and go back to the parts you've already modeled. Okay, so this one, let's go ahead and label it as sliding block. And OK. All right, I'm going to sketch on the vertical once again. Okay, and I'm going to go ahead and do a sketch starting at the origin. Just going to guesstimate the size once again. Just guesstimating. So here's a rough sketch of our sliding block. Okay, and we have a height of 6. Angle of 15. Same as the angle on the previous part. The lifting block also has an angle of 15. That's because they're going to be sliding off each other, making contact. Okay, we have a length of 100. Enter. Oh, and it got a little crazy. That's okay. Don't panic. You can simply grab this white visible line. It's not fully constrained. See, the ones that are green are constrained. I cannot move it, but I can move this white line. Don't panic. There it is. And this height is 25. Okay, so 25. There it is. There's our rough sketch there, or our accurate sketch. Do a tool sketch analysis. Everything's closed, as you can see. Okay, let's exit and do our pad. And we know we have an overall length of 90. So let's do a pad. Let's keep it symmetrical. So we're going to mirror. So we're going to go 45 in each direction. 45, and it's mirrored. That's a total of 90. So preview. Okay, 45 in this direction, 45 in that direction, total of 90. Okay. All right, so let's go ahead and sketch the slot. Okay, so here we have a slot, and it's centered. All right, so the slot has a radius of 16 and a depth of 50 to the center. Okay, so depth of 50 to the center, radius of 16. Okay, so let's go ahead and do a sketch on this bottom surface. You know, I prefer plane, so I'll pick the plane, but it's okay if you pick the surface to sketch on. Okay, well, let me rotate it. I'm going to hit the normal to rotate it, but I want the bottom, so I'll just click it again and it'll rotate it 180. There it is. Double click to dock it back. There it is. Okay, so we're going to add our slot. So once again, I like to use the elongated hole. So go to the rectangle command, go to the pull down, go to elongated hole. So elongated hole, make sure it's centered with the vertical axis. As you can see, we're centering with the vertical. That's why it's important to try and keep symmetry. Just easier later on to add more or to center your sketches, your additional sketches. All right, so we know this has a radius of 16. Enter. And we know it has a depth of 50 to the center of the arc. So depth of 50 to the center of the arc. 50 millimeters. There it is. Now, as long as this arc is not inside the solid, it can be anywhere out here in space. Just keep it outside of the solid. Okay, so let's add a dimension to the construction element. Round it off. I'll just make it 60. It doesn't really matter. You could have left it at 61. All right, let's do a tool sketch analysis. Everything is closed. Let's go ahead and exit. And let's go ahead and do a pocket. Okay, let's do a pocket. And we're going to go all the way to last. Preview. Looks good. There it is. All right, looking good. And okay. All right, so let's go ahead and do our slot here, our pocket. Okay, so we have this pocket. So the height of the pocket is 4, and we have a length of 77. Okay, so let's go ahead and do this pocket, and it goes all the way through. So once again, you can sketch on this surface. I prefer the plane, but it doesn't matter. It's just safer to do it on a plane. Now it's giving me the other side, which I don't want. Let me hit normal and hit normal again. There it is. It'll rotate it. Double click on the toolbar to set it back. It's docking position. All right, so once again, I'm going to use centered rectangle. Centered rectangle. I'm going to center it about the vertical, as you can see. So it's going to center it about that point. Keep it symmetrical, as you can see. Okay, so we know we have an overall length of 77. And we have a height of that pocket of 4. From the bottom edge to this line is 4. All right, and this line doesn't matter where it lands as long as it's not inside the solid. We can make it coincident. Now let's go ahead and make it coincident to this bottom edge. Hold on to the control key on the keyboard. Pick the edge, pick the line while holding on to the control key, and let's give it a coincidence constraint. And okay. Again, it's okay if it goes beyond the solid. All right, so tool sketch analysis. Everything's good, it's closed. Okay, let's exit and do our pocket all the way through last. So let's do a pocket. And up to last, preview. There it is, it looks good and okay. Okay, and now we need the hole. Okay, so we have a hole here of 10 in diameter. There it is, 10 diameter, and it's centered. And the center here to the hole to this edge is 10. And it's centered lengthwise. All right, so let's do another sketch. Okay, we can just place the hole and then center it with respect to the edges. Let's use that option. We don't have an arc or a circle to center it about. So let's just randomly create a hole somewhere on the surface. Obviously, we want it centered. We'll come back and adjust it. But I'm going to pick the edges. So let me turn off hole command. Let's pre-select the edges. Hold on to the control key. So you can say I selected these 2 edges before using the command. The hole command, click hole command. Place the hole. Okay, so we know it's a hole diameter of 10. It's actually a threaded 10 millimeter hole. So that's a mistake on the handout. It should be a threaded hole of 10 millimeter thread. Tapped hole. We'll just leave it as a plain hole. Either way, we don't model threads. We keep it as a plain, simple hole because threads eat up a lot of memory. All right, so now let's center it. Let me grab this dimension. Okay, we know the overall length is 90. So we'll just cut 90 in half, and this will be 45. Enter. Okay, and I selected the wrong edge. Should have been from the bottom of this edge. Let me see if I can replace it. Oh, I cannot replace it. So let me cancel and start over. It's okay, cancel. So I'm supposed to do it from this edge and this edge. Hold Command. Okay, so 10 millimeter diameter. The depth is going to go all the way up to last. Hit preview, it's going to go all the way through. Okay, now let's adjust our location. It's supposed to be centered. Okay, so half of 90 is 45. Enter. And from the bottom edge, it's going to be 10 millimeters. And okay, there it is. So 45, 10, and diameter of 10. And okay, and there's the hole. Okay, all we need now are the fillets. All right, so we're going to fillet. Now we don't want to fillet the hole, so we're going to go ahead and pick edges. All right, so let's see which edges we need to fillet. We need to fillet these edges. Again, the radius for the fillets is 3 millimeters. So we can fillet. So we're going to fillet these edges. And if we go back to the first page, we can see we're going to fillet these edges only. Okay. So it's only a few edges we're going to fillet. Okay, while holding on to the control key, I'm going to pre-select the edges that we're going to fillet. And that's it. And let's go ahead and fillet 3 millimeters. Preview. Again, we're only selecting these edges. You can always select more. Later on, if you realize that you needed more, you can always go back and select or deselect. And okay. And that's it. Looks like we're done with this one. Oh, I do need to fillet. I did miss the fillets on this side. So if we go back, I did miss the fillet here on this edge. Go back to the first page. Yep, you can see the fillet here on this edge. I missed that. That's okay. We can go back and fix it. Instead of adding a new fillet, we can just always go back to the old one. Go back to the original fillet, double click, and just add more edges. It's okay. You can go back and add more. See here, it's keeping a count of how many edges there are. 7 edges chosen. We can always go to the back here and we can remove. So you can always do it here manually, remove the edges, or you can just directly click to remove any edges that you've selected. All right, so there it is. Now we have the fillet. Everything looks good. So this is flat. This is where the other block is going to slide on. All right, so now let's go ahead and finish this off by doing the bolt. Okay, so here we have the lifting screw. So this screw has threads. We don't model threads. And it's going to engage into this hole. It's going to screw in here. And by turning the bolt, it's going to push this back and forth. All right, so let's go ahead and model let me zoom into this one. All right, so let's go ahead and we're going to draw a profile. We're going to draw half the profile and then we're going to revolve. All right, so let's go ahead and draw a rough sketch. So we'll start from this corner. We're going to go 12, right? So 12 up, 11, down, 5, up, across, and then we'll stop here, draw this line, and then we're going to do a shaft or revolve to create our solid. Okay, so let's go ahead and draw our sketch. So let's start a new file, go to Start, Mechanical, Part Design, and OK. If you want to save your other files, go for it. Just in case your computer freezes or there's a power outage, you can go ahead and save your previous files. I'll do it here at the end. Okay, so let's go ahead and sketch. I'll sketch on the vertical. Okay, let me zoom in a little bit. Okay, so I'm going to go ahead and start here at the origin. Actually, you know what? I'm going to revolve about the horizontal. So I'm going to actually start going down from here. I will start at the origin and model my way back to the horizontal axis. And then I'll revolve about the horizontal. All right, so let's go ahead and do a rough sketch. Okay, so use the profile command. Okay, so I'm just going to do a rough sketch. We know this length is about 12, so I'll just guesstimate it for now. Let me click normal. There it is. So my screen is parallel. My sketch is parallel. So I'm just guesstimating these lengths for now, and I'll come back and fix it. And I'll add the chamfers at the end. And let's go ahead and close it off. Okay, there's a rough sketch of half the profile of the bolt. Okay, so let's go ahead and add some dimensions. So this here is 12. Okay, this is 11. Let's go back to our PDF file. So this is 12, 11, 5. And this has a diameter of 10. So this is also 10. Overall length of 72. All right, so let's continue adding dimensions. Okay, so this is 11. Let me zoom in, see what happened here. So let me extend this one. There it is. Okay, so this here is 5. We have an overall length of 72. So I drew it way too short. 72. Okay, let me zoom out a little bit. There's our bolt. Okay, so the diameter of the head is 16, so I'll cut it in half. Half of 16, diameter 16 is 8. So that's 8. Okay, and the diameter of the shaft is 10. We're going to cut it in half. Radius of 5. Okay, so this is 5. And this one is also 5. Happens to be a coincidence constraint between them. If there is no coincidence constraint, you can add 5 here, just like we did to this one. That's the radius of the shaft. And finally, this has a diameter of 14. Cut it in half. Radius is 7. Half of 14 is 7. Okay, so the radius for this part, this shaft, is 7. It looks like everything is constrained now. All right, so everything looks good. Let's do a tool sketch analysis. Everything's closed. Good. Close, exit. Okay, once again, we only modeled half of our sketch, and we're going to revolve about the horizontal axis. If you don't see the horizontal here, you can always pick it from the tree. Here's our sketch. We only have one sketch. Here's the horizontal. Here's the vertical. So we're going to rotate about the horizontal. Okay, so let's use the shaft command. Here's shaft or revolve. Click, pick our sketch. And we're going to revolve. So we already picked our sketch. Here's our sketch. Let's go to the axis. So our axis to revolve about is the horizontal. Again, if you don't see the horizontal axis here, we can always pick it from the sketch. H direction, horizontal. It's already given us a preview. Hit preview. There it is. And it's rotating 360. So we went 360 degrees. If we only go 180, and click in space and then preview, see it's only going to revolve 180. What happens if we only go 90? Click in space, hit preview. That's 90-degree revolve or shaft. We're going to go the full 360. Click in space, hit preview. There it is. And OK. All right, so now let's go ahead and add the chamfers. Okay, the chamfers, it's 1 by 45. So 1 by 45 chamfers, and there's 2 of them. The 2x tells us that there's 2 chamfers. 1 by 45. Same as 1 by 1. Okay, so let's go ahead and add the chamfer. So here's the chamfer command. Chamfer, pick the edge. And we're going to go 1 by 45. Okay, preview. Okay, let's go ahead and pick the other edge. And OK. All right, the only thing missing is the hex head or the hex head opening. Okay, so here we have a hex opening, 6-sided. And it's a regular hexagon, meaning it's 10, 10, 10. And a depth, this is the depth of 9. That's how deep it goes through, 9. All right, so let's go ahead and draw our sketch on the surface or the plane. I prefer planes, but it's okay to sketch on the surface. Let's do our sketch. All right, so we're going to do a hexagon shape. Let me hit mirror so I can rotate it. My mistake, normal, so I can rotate it 180. There it is. Double click on the toolbar to set it back in its docking position. Okay, so we're going to draw a hex shape, a hexagon. Let's see if I can find hex here. There it is. Okay, so we're going to draw the polygon. Okay, so polygon. Okay, so let's go ahead and pick its center. So here's the origin, the center. Okay, so the default is a 6-sided. You can always change it here. So you do have the option to change it. Okay, so this is a regular hexagon or polygon, meaning all sides are equal and all angles are equal to each other. All right, so now let's go ahead and put a dimension of 10. Notice how it keeps everything symmetrical. There it is. All right, so do a tool sketch analysis. Close. And I want you to notice, I know I've mentioned this before and in other videos, is you want to have these on. These will automatically generate constraints when you're using the polygon command, the slot command, the centered square command. It automatically generates constraints for you. If you have these off, it will not generate these constraints. Okay, so let's exit, and we know the depth is 9. Okay, so let's do a depth or a pocket of 9. 9, and we're gonna preview. Hey, there's nothing to cut or pocket through. Okay, that's because we're going in the wrong direction. Hit reverse, the reverse button. There it is, 9 millimeters. And okay, and there's our hex shape. Okay, so we're done with our hardware here. Let's go ahead and give it some color. Properties, right click properties on the part body. I tend to make the small objects bright and the large objects, I'll give it a soft color. Let's make it a cyan. And apply. And okay. So I like to give the small items bright colors because they're easier to locate in a big assembly. And the large objects, give them a soft color. All right, so now let's go window vertical so we can see everything. Oh, I forgot to name our part. This is the lifting screw. So right click properties and let's name it the lifting screw. And okay. Okay, now let's see all the items. Let's go window vertical. So you can see we have all 4 items listed that we've just created in the past hour or so. And let's go vertical. We can see all the items. Let's go here to this one. Forgot to add color, so let me click in this window. Currently this one's blue. This is the active one. Let's click on this one. Now this is active. Right click properties, give it some color. Okay, there it is. Okay, so now we're going to make an assembly. Okay, so we have our 4 parts. Now we're going to go to assembly design or product design. Okay, mechanical design, assembly design. Let's go to that workbench. Okay, so let's do window vertical. Window vertical. Okay, I'm going to show you something new. Instead of having to go to insert the items here, we can just drag and drop. Okay, so let's drag and drop. Let me start with the base plate. I'm going to left mouse click, hold. I'm going to drag it and drop it into my assembly. There it is. Okay, let's go to the next one. So I'm going to go from large to small. Let's go to the lifting block. There it is. Let's go to the next one. A sliding block. And you tend to leave the small items for last. Bolts, nuts, washers. The smaller the hardware, the least important it is. So you place it towards the bottom of the tree. The more important parts you want at the top of the tree. Okay, so the lifting screw is last. Oh, misclick, left mouse click, hold, drag, and drop. There it is. I don't recommend dragging and dropping a large assembly into it. You can do it with assemblies too. You can have a large assembly and drag it and drop it into another assembly. Keep in mind it eats up a lot of memory. It may freeze your computer. With these small items, it's easy to drag and drop. Don't try and drag and drop a large assembly of multiple parts into another one. It'll probably work, but it may slow down your computer or it maybe even freeze it. Okay, so now let's double click on the frame to maximize. You can either maximize here or double click. All right, let me use my compass to move things around. Drop the compass on there. Let's move this out of the way. Same thing with this one. I'll select the purple one now. The screw is in there somewhere. Here's the screw. Select the screw and I'll slide it out of the way. There it is. Okay, let's reset the compass. Go to View Reset. Okay, let's give our product a name. Right-click Properties. Let's give it a name. Okay, so this is the lifting assembly. Okay, or hit Enter. All right, so let's start by anchoring the main part, which is the base plate. That's the most important part. So let's go ahead and add an anchor to that one. Here's our constraints. If you don't see your constraints, drag. So sometimes commands get buried in here, and all you have to do is just drag out toolbars. Okay, so we have our constraints. Let's double click and send these back. Double click, send them back in place. Okay, so let's start by anchoring the main part, which is the base plate. There it is. All right, so now let's go ahead and I'm gonna align the screw to the slot. Now it's an easy one. So let's put a coincidence constraint between the screw and this little slot or scallop. Make sure you select the axes. Okay, and then I need a surface to surface. So if we go back to our drawing here, let's go to the first page. So obviously this portion here drops into the slot, and this will drop in here afterwards. And then this will slide on top of this one. Okay, and it'll be centered. All right, so now let's put a contact between this surface and this surface. Okay, let's hit update. There it is. Okay, now we have, let me turn this object around. So I can use the arc of the compass to rotate it. There it is. And let's slide it out a little bit. Okay, let's reset the compass, view reset. Okay, so now we're gonna locate this hole. And again, it's a threaded hole, but we don't model threads. And this is a threaded shaft. It was not indicated in the drawing that these were millimeter metric threads. That was a mistake on my part. Okay, so let's go ahead and put a coincidence constraint from the hole to the shaft of the screw. And let's put I think that's good enough. Let's update. There it is. And we do have a little clashing here, so this is a mistake on my part. Or actually, I gotta move this way. That's what's the problem is. I gotta move this. Let me use my compass here. Let's go ahead and move this. There it is. So this is as far as it can go right there when it hits the fillet. Oh, let's see. Actually, when it hits that portion right there. Okay, so when it hits the screw, that's as far as it can go. So let me go ahead and put a constraint between this surface and this surface. Let me reset the compass first. So let's put a contact constraint between this surface on the bolt or screw and this surface. And update. Oh, there's a conflict here somewhere. It's telling me there's a conflict between this constraint and another one. So, okay. So the latest constraint doesn't cooperate with the others, so I have to delete it. Find another solution, delete. Let me try it again. Maybe I misclicked earlier. Let me do a contact constraint again. If not, I'll find another way. From this surface to this surface. I think I might have misclicked earlier. Let's hit update. Ah, this time it worked. So earlier I must have clicked the wrong surface. All right, so here we go. All right, so now I need to place this one on top. Let me rotate it first using the compass. I'm going to rotate it. It's in the wrong orientation using the arc. There it is. Okay, let's go to view reset compass. Okay, so now we need contact between this surface and this surface. All right, so let's make a contact between this surface and this surface. All right, looks good. Now we need a coincidence between the holes. So let's put a coincidence constraint between this hole and this one. And let's go ahead and update. And there it is. And I do have a clash here. So that's a mistake on my part. So actually what I'm going to do is, to fix this, I'm going to move this screw a little bit outward. Instead, I'm going to constrain this surface with this one. But then I got to remove the previous one, the earlier one. So I'm going to go back and delete the third constraint. The third constraint is a constraint between this surface and this one. Okay, so I'm going to delete that one. That contact surface, I'm going to just delete it. Hit delete on the keyboard. What I'm going to do instead is make a contact between this surface and this surface. Okay, so let's go ahead and do a contact. This inside surface with this one. And update 3, 2, 1. Update. There it is. Oh, I thought it was going to fix the problem here. Actually, it looks like it's kind of fixed. Still a little buried here. Yeah, so the dimensions on my handout was a little bit off. It's probably the reason for the... Okay, so here's the idea. The idea is, as you turn this screw, so again, the hole in this block has a thread. The screw has a thread, so when you take a wrench and you turn it, it's going to push this block forward. And it's going to lift this one upward. So it's going to be called a lifting assembly, right? As you turn the screw, it'll push this forward, or it'll push it back, and it'll lift or drop this block because of the sliding angle, while staying constrained to this hole. So most likely some type of shaft goes in here, or cylinder goes in here. Okay. All right, so we're done. So let's go ahead and save all this. Okay, notice there's no assembly inside of this lifting assembly. Notice they all have red axes, meaning they're all individual pieces. Okay, so it's only one assembly. All right, so let's go ahead and save this. Let's go File, Save Management. And let's pick the lifting assembly. Notice these are all new. The assembly is new, and each member of this assembly is new. So let's go to lifting assembly. You can see it here on the preview. Let's go to Save As, and I'm going to save it on the desktop. You can save it on your flash drive. Save it on the desktop, create a new folder. And I'm going to call it the lifting assembly. Okay, let's go ahead and, oh, I'm not in the desktop. Let's go to desktop. My mistake, go to desktop, new folder, lifting assembly. Okay, let's click on the folder to open it, and we're going to save our lifting assembly inside of this folder. Save. And then it's going to autosave everything in that folder. Notice how it's going to take everything to that same folder. There's no need to propagate. You can be safe and hit propagate. It's going to all send it all to that same folder on my desktop, the lifting assembly folder. Okay, and hit OK. All right, so let's go to the desktop. If you want to minimize everything you have open, you can just go down here at the bottom right corner, hit the little bar at the bottom right corner to minimize everything. Here's my lifting assembly. And now we can go ahead and compress it so we can email it. Go to compress, and it'll create a duplicate folder that's compressed. That'll eat up less memory, and you can go ahead and email me this zipped folder. Okay, so this is the end of the lifting assembly video.